From dual winch tractors pulling with restraint to cable mast systems lifting logs above fragile ground, this is forestry built on control, not force. Watch timber lifted, guided, stacked, trained, and hauled across mud slopes and tight corridors with precision. Every pull is planned, every load balanced, every movement repeatable. This isn't chaos in the forest. It's discipline, machines, and technique working together to move wood the smart way. Operators guide the Mountie 4000U, lift liner, and Woody H61 to organize logs efficiently on forestry ground. Logs arrive stacked, then move one by one into controlled positions. Grip pressure stays balanced to avoid surface damage. Feed rollers pull steadily while length measurement stays consistent. That smooth pull feels oddly calm for such force. Cut points follow preset values without hesitation. A clean cut always lands with a sharp final snap. Sorting follows immediately, separating lengths for transport. Compact motion keeps the load predictable. Hydraulic responses stay even during quick adjustments. No sudden jerks here, steady confidence. As those sorted lines settle into place, the workflow shifts from preparation to movement. What was once about precision cutting and clean separation now becomes about carrying that order forward without losing it. The pace doesn't spike, it translates. Each log leaves the controlled handling zone already aligned, already measured, ready for the next machine to take responsibility. That's where extraction takes over, turning neat output into mobile weight that has to stay balanced, oriented, and cooperative as it moves deeper into the operation. Timber extraction and positioning are carried out by the LP49 during continuous forest operations. Hydraulic arms grip and release in repeat cycles, keeping stems oriented for clean stacking. That clamp timing decides whether a log settles or slides. Travel paths stay tight to reduce wasted motion between piles. The machine looks bulky, yet its turns stay surprisingly compact. Loading continues as bundles are squared and raised to transport height. Weight stays centered to avoid side lean while moving across uneven terrain. Seeing a full bundle lift clean never stops feeling tense. Placement follows a clear order, building stacks that stay stable under their own mass. One crooked log can bully the rest out of line. Between runs, the LP49 repositions and repeats, favoring consistency over speed. From there, the perspective widens. Individual machines and tight, repeatable motions start to read as part of something larger, stretching across hours instead of minutes. Each grab, lift, and placement feeds into a rhythm that lasts all day, not just a single cycle. What looks like isolated handling becomes a chain. Planning in the morning, movement through the terrain, order at the landing, and reset for what comes next. Follow a full workday inside the forest, with timber moving from standing trees to stacked logs through coordinated forestry operations. The day centers on harvesting, extraction, and handling, showing how multiple tasks connect across terrain. The morning phase focuses on tree selection and directional felling aligned with access routes. Cuts are placed to guide trunks into clear zones, keeping paths predictable for extraction equipment. That early planning quietly decides how smooth the rest of the day will run. Logs are delimbed and sectioned to lengths suited for transport, keeping the workflow consistent across the site. Clear spacing between processed logs keeps machinery access open throughout the morning. Extraction shifts attention uphill and downhill as logs are moved toward collection points. Trunks travel along prepared corridors instead of random paths, limiting surface disturbance. Seeing wood move along the same lines again and again changes how the ground holds up by afternoon. Machines pause, reposition, and continue without rushing the sequence. This is the part where patience pays rent. Repeated alignment reduces handling corrections later at the landing. At the landing, sorting takes over. Logs are grouped by diameter and length, building clean stacks ready for haul out. The piles start to look like inventory instead of debris. Handling stays deliberate, keeping stacks stable as loads increase. One wrong grab here would turn order into chaos fast. Transport preparation closes the cycle. Loads are aligned for trucks, spacing is adjusted, and the site resets for the next round. It hits hard how much coordination hides inside something called a normal workday. The forest doesn't feel paused, just managed. Throughout the day, repeated routes and controlled movements limit unnecessary ground stress. By evening, the area remains navigable, stacks are ready, and operations leave fewer traces than expected. That balance between output and restraint is what carries the work forward. Zooming in from the full-day flow, extraction becomes the hinge point where planning meets terrain. This is where order either holds or unravels under tension. Instead of fast passes or brute force, the work narrows down to controlled pulling, keeping lines clean, loads predictable, and ground impact minimal. That mindset sets the stage for a different kind of machine focus, where restraint matters as much as power. Enter the Uniforest 2X100H on the Valpro Forest tractor, a setup built to pull with intention rather than rush. Every pull from the Uniforest 2X100H on the Valpro Forest tractor focuses on steady extraction rather than aggressive force. Built around coordinated pulling power rather than speed, this setup focuses on controlled log extraction in demanding terrain. The tractor base supplied by Inter-Export provides the platform, while Pro Jurnak S upgrade reinforces stability and mounting integrity for the twin winch system. Positioning comes first as the tractor is guided to maintain line control before any load moves. The dual drums operate independently, allowing operators to manage separate logs or balance tension across uneven pulls. Cable routing stays clear to reduce snag risk, and braking response remains consistent through each pull cycle. That balance between force and restraint feels stronger than expected for a compact forestry rig. Once tension is applied, logs slide steadily toward the tractor without sudden jerks. The winches maintain even winding, helping prevent cable overlap and uneven spooling. Anchor points stay firm, keeping the tractor planted during heavier pulls. That steady drag looks like the machine already knows how much force is enough. As extraction continues, operators adjust pull angles to guide timber into cleaner paths. This minimizes ground disturbance and keeps logs aligned for the next stage of handling. The tractor's forest configuration supports repeated cycles without repositioning after every load. Seeing two winches share the work makes single drum setups feel strangely limited. Throughout operation, the Uniforest 2X100H demonstrates why dual winch control matters in real forestry conditions. Each pull remains deliberate, predictable, and repeatable. The setup prioritizes reliability over flash, delivering consistent results across multiple extraction runs. This feels like a machine designed for long days, not short demos. Video production by Alenfra Productions captures the interaction between tractor, winches, and terrain clearly, keeping focus on function rather than spectacle. By the end, it's hard not to respect how calmly this system handles serious pulling work. That calm, deliberate pulling philosophy doesn't end at the winch. Once timber is free from the stand, the challenge shifts from breaking tension to keeping control while moving uphill. Extraction turns into hauling, and hauling on steep ground exposes every weakness in traction, balance, and timing. This is where assisted movement matters, where the load doesn't just follow, but actively helps itself climb. That transition leads straight into the Silao ASAS Arion 550, paired with the Steppe M16, a combination built to turn slopes from a hard limit into a workable path. Logs are loaded in the ravine, balanced carefully to keep the tractor stable before climbing begins. Load height stays moderate to reduce rollover tendency on cross angles. Weight distribution matters here, because traction fades fast on steep ground. Axle load consistency determines whether the tractor maintains steering authority. The trailer's driven wheels engage through onboard hydraulics, pushing together with the tractor instead of dragging behind. Power transfer shifts from passive rolling to active ground engagement. That extra push changes everything. Rear slip remains limited even as gradient increases. Each pull stays controlled, avoiding wheel spin that would stall progress. Controlled traction preserves tire surface contact under variable soil firmness. Steering inputs remain subtle while the load follows the line without folding the drawbar. Near the crest, traction becomes the main challenge. Ground contact decreases as slope angle peaks. The driven wheels continue feeding grip into the soil, preventing rollback under load. Forward motion stays continuous without abrupt stops. Hydraulic response stays predictable, letting the operator fine-tune assistance instead of guessing. Drive engagement reacts consistently to throttle changes. Miss that timing and gravity wins fast. Rollback risk rises sharply at transition points. Once the slope eases, hauling transitions back to standard rolling resistance, and the trailer disengages extra drive as conditions allow. At the landing, unloading follows an orderly sequence. Load release occurs without sudden mass shift. Logs slide free without sudden shifts, keeping the tractor planted. Chassis balance remains unchanged during unloading. The combination shows how assisted trailers expand working range on terrain that would stop conventional setups. Slope capability extends beyond traditional skidder limits. Hard slopes suddenly look negotiable. Operational margins widen on difficult extraction lines. This operation highlights how mechanical support and controlled driving replace raw force, turning difficult extraction into repeatable work. Once timber is moved, stacked, and hauled clear, the job doesn't end. It changes shape. What's left behind is ground that still needs attention before the next use can begin. Extraction and transport create access, but preparation decides whether a site is truly finished or just temporarily empty. This is where operations shift from moving wood to reshaping the landscape itself. Instead of lifting and hauling, the focus turns to cutting, grinding, and reducing everything that remains in place. That transition leads into the tracked MS-N10 Getty M Mulcher, built to erase what extraction leaves behind and leave the ground ready for whatever comes next. The hydraulic transmission delivers constant torque, while electronic control allows precise response to load changes. This thing does not hesitate once it commits. Material reduction happens as the mulching head engages standing trees and embedded stumps, breaking them down in place rather than pushing debris aside. The design allows work along power line corridors, oil and gas pipeline routes, and transport right-of-ways where surface disturbance must stay controlled. You can tell this setup was made for tough terrain, not tidy parks. On construction sites overgrown with shrubs and small trees, the tracked chassis distributes weight evenly to reduce ground damage while maintaining traction. For forestry maintenance, the mulcher clears logging areas by grinding stumps and processing leftover cutting residues into manageable fragments. That moment when stumps disappear instead of fighting back feels oddly relieving. Production of the MSN-10 GTMM takes place in Barnaul, Russia, where the focus remains on adapting heavy equipment for demanding field conditions. The result supports continuous operation in remote zones, helping crews prepare land efficiently for infrastructure, forestry, and development tasks. Before cutting or clearing even begins, control has to come first. Some operations aren't about removing material yet, but about taking hold of it, deciding where a tree will move, how it will fall, or whether it falls at all. This is the quiet moment before force is applied, where positioning matters more than speed. Handling standing timber safely sets the tone for everything that follows. That's where the fall griefer JAK-20X steps in. Built to grip, guide, and place trees with deliberate hydraulic control instead of brute motion. Mounted on a carrier, the unit approaches each tree with jaws open, aligning the frame to keep the stem centered during contact. Hydraulic arms close firmly around the trunk, locking it upright while the carrier stabilizes its stance. That locked hold already tells you this tool works through control. With the tree secured, the grapple maintains vertical balance, while the base machine manages ground pressure and reach. Rotation functions allow the operator to guide the stem's direction, keeping surrounding trees clear during handling. The motion feels closer to placing objects on a shelf than wrestling weight. Once positioned, the grapple supports controlled lowering and placement, keeping the trunk steady through every degree of movement. Load transfer stays predictable because the grip remains constant throughout the sequence. No sudden drops, no guessing, just steady force doing exactly one job. When ground access itself becomes the risk, even the most controlled machines start to feel too heavy. Slopes steepen, soils soften, and suddenly traction and balance aren't the main concern anymore. Impact is. At that point, the question shifts from how to pull timber to whether it should touch the ground at all. That's where extraction lifts away from wheels, tracks, and winches and moves into the air. The Force Technic cable mast technique answers that shift by carrying loads above the slope, letting gravity work without letting the ground pay the price. Designed for steep or sensitive terrain, the cable mast setup shifts loads above ground instead of dragging them through soil layers. That choice alone changes how forestry operations interact with the landscape, prioritizing stability and ground preservation over brute pulling. Load transfer stays airborne along most of the travel path, keeping weight off exposed soil layers. System setup establishes anchor points and mast alignment to define the working corridor. The mast supports elevated cables, creating a suspended path for logs to travel without scarring the forest floor. Load paths are planned carefully to maintain balance across the span. That elevated movement feels like forestry learning to tiptoe instead of bulldoze. Once tension is applied, logs lift gradually and slide along the cable route. Operators adjust carriage speed to match slope conditions and log weight. This keeps stress off roots and minimizes soil compaction along extraction lines. Seeing timber move without carving ruts into the ground feels quietly powerful. Controlled lift height limits ground contact across uneven terrain. As extraction continues, repeated cycles follow the same corridor, reducing the need to open new tracks. The system allows selective harvesting without disturbing surrounding stands. Load control remains consistent, even across longer spans. That kind of control makes ground-based skidding seem unnecessarily rough. Consistent routing maintains predictable clearance throughout each pass. Throughout operation, the cable mast technique shows its strength in terrain where conventional machines struggle. By transferring force upward, pressure on soil drops significantly. This supports regeneration and keeps access roads usable over time. It's surprising how much damage disappears once the ground stops carrying the load. Reduced ground loading preserves surface structure along extraction lines. Operators coordinate mast position, cable tension, and carriage return to maintain steady throughput. Each cycle aligns with the previous one, keeping work zones predictable. The flow feels steady enough that the forest almost gets a break between pulls. The approach favors long-term site health rather than short-term speed. Repeatable cycles stabilize working conditions across the site. Force Technics' cable mast solution highlights how technical choices shape environmental outcomes. Instead of forcing machines across fragile ground, the system adapts extraction to terrain limits. This setup feels less like conquering nature and more like negotiating with it. The result is a forestry method that balances productivity with preservation, especially in areas where soil protection matters most. After lifting timber off the ground and moving it through the air, the workflow eventually settles back onto soil, where control has to be earned again, not assumed. Once conditions allow, extraction returns to ground contact, but with the same emphasis on balance and restraint. The focus shifts to keeping loads aligned, traction consistent, and movement predictable as timber travels along prepared paths. That's where the EQUUS 175 NUN forestry tractor comes into play, translating careful planning into calm, controlled skidding rather than raw pulling. Power delivery stays steady, while the drivetrain keeps traction under load. Weight balance supports controlled movement during skidding and repositioning. Steering response stays tight during turns, keeping loads aligned. That calm pull under strain says a lot about the machine's intent. The tractor maintains pace without rushing, showing how forestry hauling rewards restraint over aggression. All that control in the field doesn't come from instinct alone. It's trained. Machines can stay balanced and predictable, but the person guiding them still has to read tension, anticipate release, and choose the right moment to act. Before those judgments are made in real timber, they're built somewhere safer, where force can be felt without consequences. That preparation leads away from the forest floor and into training itself, where the Serra Cut Coach simulates tension and release, so operators can learn what stored energy really does, before it ever surprises them on the job. The Serra Spanning Simulator, also known as the Cut Coach, is designed to train operators for tension cutting situations without real danger. The setup recreates bent tree behavior using controlled force, allowing users to practice release cuts under realistic stress conditions. The training unit positions a simulated trunk under adjustable load, creating predictable bending forces that mirror real logging risks. Operators study fiber direction, pressure zones, and reaction paths before placing each cut. As cutting begins, the simulator reacts immediately, showing how stored energy releases through the material. The controlled environment allows mistakes to happen safely, which makes learning faster and more honest. That snap of movement after the cut is sharper than many first-timers expect. Repeated sessions help operators recognize warning signs earlier and adjust stance, cut depth, and timing. This kind of practice turns hesitation into calculated action, not rushed guesses. By isolating risk without removing realism, the Ceracut coach builds habits that carry directly into forest operations. Training like this explains why fewer surprises show up on real job sites. Knowing how tension behaves is only half the equation. The other half is where that force goes once the pull begins. In dry, firm ground, mistakes show up fast. In wet or unstable terrain, they linger as damage. This is where extraction design has to manage not just load weight, but how that weight presses into the ground with every meter traveled. After training teaches respect for force, real machines have to apply it gently. That's the gap the KMC 2400 HSST swamp skidding system fills, turning heavy pulls into controlled movement across ground that can't afford abuse. Built for steep slopes, boggy zones, and sensitive soils, the KMC 2400 handles pre-bunched logs using a pin-on grapple. That elevated arch design changes how weight behaves once logs leave ground. The hydraulic arch reaches toward the load, then retracts while lifting log butts over rear deck. This shift pulls mass closer to the machine's center of gravity, cutting butt dozing and stabilizing movement. Balanced distribution improves traction and allows faster travel without tearing soil layers. Dynamic ground pressure stays low while hauling larger diameters. That's the kind of detail operators notice after long pulls. Repeated skidding cycles follow predictable paths, keeping surface damage contained. It feels less like dragging timber, and more like carrying it with intent. The KMC 2400 shows how controlled force moves heavy wood across terrain.